Hello YouTube Vintage Stereo Restores. So I think we're at part 6 now of this Kenwood KA2000. I know I've called it the Kenwoody and the Kilcar and the Larney. I just have fun with words. This is the service manual you can download. You can also just get the schematic. It's available in a couple places. The KA2000A is very similar. In fact, there's some improvements in it that I put into the older ones, and when we get more into the recapping, I'll tell you what they are. They're adding a couple extra capacitors around the transistors so that they don't oscillate. But what we're talking about today is rebuilding the power supply, and the power supply in this one is originally comprised of a 2200 microfarad 50 volt, a 1000 microfarad, and these are both up here, and I was able to find very reasonably these Nishikon 3300s, and it will fit in the clamp. It's got a little different terminals on the bottom, but you can easily get wires onto these. We're only putting 1 or 2 wires on each one, so that'll fit in. Then in place of the 1000, that one will go in right there from the top. It'll fit the clamp. These are a little higher voltage, but absolutely nothing wrong with that. In fact, it improves longevity. This 220 microfarad here, which basically is the last filtering between the tone control board, the phono stage. And I've got some 250 microfarad 50 volts. You just need a little longer lead length. But if you have like some radial ones like that, you can use them as well. And you can always add a little bit. Sometimes I have, I add a piece of wire and then put some spaghetti tubing over it to make it a little longer. Anyway, now you can replace those. You could reuse the resistors, but there's a couple extra things I like to do on these. One here is the diode bridge. So this is a full wave rectifier in those 2 diodes. It actually uses the center tap of the transformer, so in that design you only need 2. And each diode has a 0.022 microfarad cap in series with it. Sorry, in parallel, what am I thinking? I've always had trouble with that. I know what I mean, but then I say the wrong word. Anyway, that oil-filled cap tends to go bad. In fact, these ones, I'm surprised they're not seeping. But think about how many times that's charged, and then released, because it's basically quieting the switching action of the diodes. So what you do is we'll make another one with a diode like this, wrap the leads around it, put it in correct polarity. It would actually be like that. So it would look like something like that, using the polyester, the 600 volt ones. And then of course, so there's 2 and 2. Then what you're left with is optional to replace this. This is basically across the power switch, even though it's down there. It's a 0.01. These, I've had found a couple of these where these leads have been broken, and I don't know what it is. You think it wouldn't be touched or moved, but sometimes it's just the way it is. I'm going to replace that one anyway. A 0.01, take a little less room under the hood, Now what you're left with is 3 resistors. This reddish orange job here is a 1000 ohm. How do I know that? I've done a couple. I actually made a diagram. It's on the schematic. I'll find it. I know I made a diagram of this. Oh, there it is. There's the schematic. And in the corner is my engineering quality diagram. And you might laugh at that, but I used to work on these multi-million-dollar telephone switches, and you often had little things. We had these big plans, pages and pages of schematics for the switch. And you'd often have doodles from techs and engineers in the margin saying you need to do this, you need to move this resistor, whatever, to solve this problem. Anyway, as long as somebody can make sense of it. But you can get the values off there. So rather than trying to stretch them to the new ones, because they didn't leave any slack except maybe this one. So the 1000 ohm is a 2 watt. So there's a 1000 ohm with another new 2 watt. What I'm going to do is I'm going to move it over here, so it's not between the leads. As you should have as few as possible components on the leads of a cap, in my opinion. There's a 4.7K bleeder resistor over the 1000 microfarad. So there's one to replace that. And then you only need like a 1/4 watt 220 ohm to this circuit here that feeds the 220 microfarad. And you can actually, I think we can actually, yeah, we'll just work it in there. So this one here, this 47 ohm resistor, there's a second set of contacts in the power switch. What it does is when you turn the power switch off, it goes between ground and this cap and bleeds it, drains it. So on these, when you shut them off, you very quickly lose the sound. Other amps that don't have them, you can shut it off and listen for like 2 minutes because the caps are so big. And as far as upgrading cap sizes, I'm very happy to make the 2200 to 3300. That is the best place to improve it, right there. The 1000, another 1000 works. 2200, I put as much as a 4700 in here and a 4700 in there, and I can't tell the difference the way the amp works. So I think you're losing ground if you go too big. And then a 250 for a 220, that's perfect. Anyway, what I'm going to do is, rather than take like, this will probably take 3/4 an hour to an hour to rebuild, to clip it out and desolder and stuff. It's kind of boring to watch, but you'll get to see the finished product when we jump on the next video. Thanks for watching and listening.